creating the frequency table is the most time-consuming part of this lecture. Once you have your table completed, then creating the graphs to go with the tables goes fairly quickly. So this next portion is on frequency graphs. In other words, using your tables to create visual graphs of the data in your data set. We've all heard that a picture says 1,000 words. Well, that holds true for statistics as well. So why look at thousands of original data points or look at frequency tables when you can draw a graph? And so we'll talk about two different types of graphs in this lecture. We'll talk about histograms and frequency polygons. So we'll first talk about histograms. And the first thing you need to know about histograms is that it's used for continuous variables only. So remember, continuous variables are scale or score variables. In particular, they're interval or ratio variables. So we need to know the type of variables we have in order to tell if we need to draw a histogram. Now there's three basic steps to drawing a histogram. The first is to draw an XY axis, where the x-axis is your horizontal line, the y-axis is your vertical line. Once you draw your axes, you then need to label them. You also need to give your graph a title. So don't forget to give it a title. That title should be descriptive of the variable that you're graphing. Now on the x-axis, you may or may not include a 0 point. If it's practical to include a 0 point, go ahead, but if not, start where your data begins. So if your data doesn't begin until a value of 12, well, there's no reason to create dash marks from 0 to 12. Start at 12, break your axes, and start at 12. The last step is then to draw a bar for each value or interval midpoint based on your frequency table. So you remember the frequency column in your frequency table has values in it. You want to draw a bar that represents each of those intervals from your frequency table. Here is the frequency table from our juvenile delinquency data for the first part of this lecture. So you'll notice in this table that I've added a column. I've added a column for midpoints. So when we graph our histogram, we don't want to use the intervals on our x-axis. We actually want to use the midpoints of each of the intervals. And so the best way to get the midpoints is to take the very first interval and take the first value in that interval, in this case 8, and then add it to the very first value in the next interval, so 9.5. So we'll take 8, we'll add 9.5, and then we will divide that number by 2. So if I take 8, I add 9.5, I get 17.5, I divide that by 2, and I get a midpoint of 8.75. And so that will be my very first midpoint for the first interval. If I want to get the second midpoint for the second interval, I could go through that process again. I could take 9.5, add it to 11, and divide by 2 and get 10.25. Or the easier way is to take the midpoint of my first interval, 8.75, and add the interval range. And so if you remember, the interval range was 1.5. So I can add 1.5 to 8.75, and I get 10.25. So either way, I can get the midpoints for each of my intervals. I think the easiest way to do it is to calculate your very first midpoint and then add the interval ranges to that very first midpoint. And I think that's the fastest way to do it, but you can do it by calculating the first value in each of the consecutive intervals and dividing by 2. I think that just takes more time. So here are all the midpoints for our frequency table. And so remember, we got that very first midpoint by taking 8, adding 9.5 to it, and then dividing by 2, and that gave us 8.75. Once we have that very first midpoint, we can then add our range of our intervals, which was 1.5. And so I take 8.75, add 1.5, I end up getting 10.25, and there's a midpoint for my second interval. If I add 1.5 again, I get 11.75, and that's the midpoint for my third interval. And I can keep going down my table. Once I have my midpoints, I can then go ahead and create my histogram. So remember, there's 3 steps to creating a histogram. The first one, the very first step, was drawing your XY axes. And so we'll draw a line for our x-axis, that's the horizontal line. We'll draw a line for the y-axis, that's the vertical line. And that will begin our histogram. Now the second step is to label your axes and give your histogram a title. And so in this particular case, we'll label the x-axis the midpoints of the number of juvenile school disciplines. And so note that that label represents the unit of measurement that's going to be on that x-axis, in this case midpoints, and it also represents the data or the measurement itself, number of juvenile school disciplines. And so you should have both of those in your label for the x-axis. Note that the units of measurement there are the midpoints, they are not the intervals. So make sure on the x-axis you put your markers as the midpoints and not as an interval range. So if you look at the y-axis, we see we've labeled it frequency, and so if you remember, that's the third column in our table, is the frequency of the values that falls within the intervals, and so that's where we're going to draw our bars up to those particular lines that represents the frequency. So frequency on the y-axis, the midpoints of the measurement of our data set, it goes on the x-axis. Alright, you want to give your histogram a title. The title should reflect both the x and the y-axis. So in this case we have frequency, that's on the y-axis, and we have delinquent school discipline, and that is the x-axis, so we can say frequency of delinquent school discipline. So both the x and the y-axis should be represented in the title. Finally, the last thing we need to do is to draw our bars, and so we'll look at each midpoint and we'll draw a bar up to the frequency that's represented in our table. So if we look at the very first midpoint of 8.75 and we look at our table, we had a frequency of 3. So we draw a bar up to 3. With our midpoint at 10.25, we had a frequency of 1, so we draw our bar up to 1, and so on and so forth through our table. Now there's two things that you should note with this table. The first is that the bars touch. The bars will always touch in a histogram. So if you're drawing a histogram, the bars should touch. The reason why is that the variable on the x-axis, the values on the x-axis, is a continuous variable, or they're continuous values. So because they're continuous, remember the types of variables that we have, because they're continuous, the bars are going to touch. There's no break between the numbers. So the bars will touch in a histogram. If they don't touch, then it's called a bar graph or a bar chart. And so in this particular case, they touch, it's a histogram. The other thing I want to point your attention to is that notice on the x-axis there is a break in the x-axis. So in other words, there is a blank spot represented by two dashed lines. That tells the viewer that our histogram does not start at 0. So in this case, it's starting at the midpoint of 8.75. It's not starting at 0. So to keep our graph from being extremely long, we create that break, and we started at 8.75. Now had we started at 0, there would be no reason to break the axes. So in this particular case, we don't start at 0, we start at 8.75. So we need to indicate to the viewer that we're not starting at 0, and we break that axis. That will always be the case when we draw graphs. If we don't begin at 0, we need to break the axis. The other graph that we're going to learn in this lecture is the frequency polygon. The frequency polygon is just like the histogram in that we use continuous variables. So if our variable is an interval variable or a ratio variable, then we're going to draw a frequency polygon. Alright, so in our steps, you'll notice that they're exactly the same as a histogram. The only difference is that we're not drawing bars now. We're actually going to draw a line graph. And so for at each midpoint, instead of drawing a bar, we're going to place a dot that represents the frequency for that midpoint. Once we have all our dots in our graph, we will then connect the dots. And so we'll end up with a line graph that we'll call a frequency polygon. Here is the frequency polygon for our juvenile delinquency data. Note again that we're not using bars here, we're using lines. You should also note that the labels and the title are exactly the same, that there's no difference there, that we're still measuring frequency on the y-axis and still the number of juvenile school disciplines on the x-axis. Note again that we're going to break the axes just like we did with the histogram because we're not starting at 0. Now you will note that there are two extra midpoints in this graph. So with our histogram we started at 8.75. Here we started at 7.25. 22.25. And then we ended at 23.75 instead of 22.25. The reason for this is because we're using a line graph. In this case, we'll say it represents a population. So when we say that our data represents the population, what we're saying is, as a researcher, I don't care about anyone else but the 24 juveniles that I've measured in my data set. So we'll call that the population. If that's the case and we're drawing a frequency polygon for the population, then we need to connect our line graph back to the x-axis. So you'll note that at the midpoint of 7.25, the line goes all the way down to 0 and touches the x-axis. That indicates to the viewer that there are no values below our midpoint of 8.75. So 7.25 and below, there are no frequencies or no values in the population. Same thing at the top end, that when we connect the line at 23.75 to the x-axis, we indicate to the viewer that there are no observations or no people with values of 23.75 or higher in the population. Now, if we were creating a frequency polygon for a sample, we would not connect it back to the x-axis. We would just leave those lines floating on the graph. And that would indicate to the viewer that we have a sample and that the population is much larger and there could be values lower than our midpoints of 8.75 or higher than our midpoints of 22.25. So just remember that if you're creating a frequency polygon for the population, you connect your line graph back to the x-axis. If you're creating a frequency polygon for a sample, you do not connect your line graph back to the x-axis. You leave it floating in the. Now that we know how to draw histograms and frequency polygons, let's talk about when we use them. So if you remember from the lecture, we use histograms and frequency polygons when we have a single variable, so one variable that we want to visually represent, and that variable is continuous. In other words, it's a score or scale observation. So that would be an interval or a ratio variable. Now, if our variable was a discrete observation, in other words, it was a nominal variable or an ordinal variable, so discrete variables, whole numbers, then we would not use a histogram or a frequency polygon. We would then use a bar chart. So remember, when we're drawing the histogram, because it's continuous, the bars touch each other. However, if it wasn't a continuous variable, it was a discrete variable or a grouping variable, then we would use a bar chart where the bars do not touch each other. That is why it's important for us to know the types of variables that we're working with, which is also why we categorize those variables, because the type of variables that we have will tell us what type of graph we should draw. So if I have a single variable or one variable and it is a continuous variable, so in other words it's interval or ratio, then I'm drawing either a histogram or a frequency polygon depending on the purpose of my graph. So if my graph is to present my data, so let's say present at a conference or present in a class or in a lecture or in a journal article or a magazine, then I'm going to draw a histogram. But if my purpose is to compare my graph to another graph, let's say a normal distribution, then I'm going to use a frequency polygon. Why that's incredibly important is that the normal distribution, which we haven't talked about yet, is a line graph. And so I want to compare a line graph to a line graph. So compare the normal distribution, which is a line graph, to my frequency polygon, which is also a line graph. I don't want to compare a line graph to a bar graph. So if I have a single variable, but that variable is a discrete variable or a grouping variable, so in other words it's an ordinal variable or a nominal variable, then I'm going to use a bar graph. And so the difference again between a histogram and a bar graph is that in a bar graph the bars don't touch each other. They're discrete, and so it's not continuous. The x-axis doesn't continue on, and so we create breaks between each of the values in our data set. And so if we have a single variable and it's a nominal ordinal variable, then we will use a bar graph. The reason why we care about the shape of the distribution is that most of the statistical tests that we use for our data has an assumption that the data is normally distributed. Now, we haven't talked about normal distribution yet, but we will in the next section. But if our data is not normally distributed, then we have to be cautious with our statistical tests. In other words, our results may not be valid. So it's important that we know the underlying distribution of our data, and it should be a normal distribution.